Welcome, everyone. I'm so excited to be here. My name's Jen Stave. I am the launch director for Digital Data Design Institute, and we are really, really excited to have you with us today. Really happy to partner with the HBS Club of Northern California and Google Ventures to put this on. Before we get to the main act, the Karim Show, and actually, how many of you have seen the Karim Show? Okay, for those of you who haven't, you're in for a treat. For those of you who have, you're still in for a treat, because I've seen it about 20 times now, and every time I still learn something new. So it should be exciting. But first, I want to share with you about the Institute. How many people know what D cubed is? Not enough. Okay, let me tell you 3 important things about it. First is that we study AI and digital. Now, that's not very novel these days, right? The difference is we like to say that AI is only part of the story. So what we focus on are the operating model and business model changes needed to truly leverage that technology. So when you look at our research, you see labs like a pricing lab. You see labs like a reskilling lab. All of these fundamental parts of business that have been around a very long time that are now changing in the face of AI. So that's the first important thing. Second important thing is that we do translation science. So we do applied research. We're not theoretical. We work with companies to understand where they are at the forefront of AI, and then we partner to push that farther, to understand, to run experiments with our Harvard faculty and understand how we can drive the future of business. So any of you who are engaged in a company who's dabbling in AI, pushing the boundaries, come talk to me, come talk to Karim. We want to figure out how you can work with us. The third important thing about our institute is that we do things a little bit different at HBS. We are a little bit of a black sheep, or like Karim is known as a bit of a rebel, so we've taken on that personality. And we do research differently. So in the social sciences, it's very common for researchers to work independently and study and tackle a problem. In the hard sciences, they work more collaboratively in labs. And so you have a whole cohort of researchers working together to push the boundary faster and to ask bigger questions, more ambitious questions. So we took this model of research from the hard sciences and we applied it to the social sciences. And this is really not done a lot. And so we've been working with about 40 Harvard faculty, most of them from HBS, teaching them how to do this new way of research that will allow them to ask bigger and more ambitious questions. And so in the end, once we're fully scaled, we should be able to really be global thought leaders on some of the most difficult questions facing us in AI and digital. I say when we're fully scaled because we're still just in our nascent stages. We're only 18 months old. And so we are out doing these tours to talk to people, get them engaged, get them understanding what we're doing, and be part of our community. And so with that, I will hand it over to Karim to tell you more about it.
Okay, thank you, Jen.
Yeah. That's for your slides. Do you want to try the mic?
No,
Okay.
Can you guys hear me okay? Yeah? Okay, awesome. First, many thanks to Dave Minichello and the Google Ventures team for hosting us here. Dave is actually a former student, has gone on and done amazing things. I'll take all the credit for it. And really is also part of our advisory council. And the advisory council is really helping us figure out what this institute is and what it wants to be and how do we get there as well. So again, very appreciative to Dave for, so we'll like have D-Cube West office here, in the future, thanks to Dave. So it's important that we recognize that. Secondly, our team, some of them are home back in Boston, some are here, really helped set this up. So I just show up and I'm a robot, they press play and I spring into action. But the team is really, really important. And the progress we've made over the last 18 months in launching this institute, which I still feel is going too slow, but others say is going at light speed according to Harvard standards, has been because we have a great team and Jen Stave has been leading that effort as well. So it's really important. And what I'm going to do today is sort of really dive into the question of the century, I guess, in many ways, which is around generative AI and what it all means. So I'm going to walk you through a perspective. We actually have data and experiments to back it up. And then again, if you have questions, please interrupt. Please ask questions, along the way. I could go on forever, so they'll stop me eventually. I'm going to tell you about two books. The first one is Azim Azhar, former BBC journalist, great podcast called The Exponential Views. And this book really talks about the fact that there's a bunch of technologies that grow exponentially and companies that grow exponentially with them. So certainly AI, synthetic biology, additive printing, and solar. And then, so what you imagine is that there's companies and technologies that grow exponentially, but the rest of us grow linearly, right? Harvard Business School doesn't grow exponentially. Harvard Business School grows linearly. And that creates this gap, right? Both a risk and a threat, but also an opportunity, right? And so this book really lays out for us that we've sort of entered through technologies, especially AI now and what it does, in this exponential age. And most of our institutions, most of our companies, most of our norms, our expectations don't know how to deal with it. And if you recall, this is also what happened with COVID, right? You have an exponential disease process, right? And we had hospital capacity that only grew linearly, and then we had shutdowns and lockdowns, right? Because as humans, our systems aren't set up yet to deal with exponential tools. So this is the world we live in. And a book that I wrote with Marco Ianciti, a colleague of mine and a friend and a mentor, the guy who got me to HBS and made me stay at HBS because I tried to leave many times. We wrote this book based on a course that we developed in 2013 that we taught for 6 years called Digital Innovation and Transformation. This book really sort of argues that the architecture of businesses is changing because of AI. How you create value, how you capture value, your business model, but also importantly, your operating model, how you achieve scale, the number of customers you serve, scope, how you offer them many different things, and then also learning, how you keep learning. My first job was at a Baskin-Robbins, scooping ice cream in high school. But my first real job out of college was at General Electric. Right, and GE was the bomb in the 1990s. Right, that was the company. That was like the Google of the time. Anybody would want to go work at GE, and the GE business structure was established really in the 1920s. If you sort of think about Alfred Sloan and the multi-business unit company that was set up, right, and that blueprint has basically sustained for about 100 years and has brought us this modern economy today. But starting in the 2000s, right, companies here in California started to sort of rethink what was at the core of a business. And they rethought both the operating model and the business model. And this book basically argues why that is the case and what that means for us. And to give you a perspective on this, in our book, we talk about this crazy company called Ant Group, Ant Financial. Today, they've been sort of defenestrated by the Chinese government. But, they grew from a payments platform for Alipay, so basically PayPal for eBay, for China's eBay. But they have grown exponentially, right? And have 1.2, at the time we did the study, 1.2 billion users, but only 15,000 employees, right? So that's a very different company, right? I've had Bank of America for the longest time as my bank. I'm locked in. And I think my calculation was that for Bank of America to serve 1.2 billion users, they need like 200 million employees. Just the way they run. Sorry if there's any Bank of America people here. I have a lot of complaints to you guys. And the problem is because our processes are still stuck in the last century, and we haven't updated them, and we haven't digitized them, we haven't done them. So the thing that is the remarkable about this is, right, again, this fact of 1.2 billion users, 15,000 employees. They have a thing called 310. 3 minutes for any kind of a application, a new loan to apply, 3 minutes to apply, 1 minute for approval, right? And zero human intervention, right? Zero human intervention. And so again, just imagine what you need in the back office to be able to pull that off at a scale of 1.2 billion users, It's a very different company than we're used to thinking about. And their model, slide is a bit off. Their model really is, they're a multi-sided platform, and the logic is as they get more data, they can build better algorithms. As they build better algorithms, they build better services. As they build better services, they get more usage. And this flywheel. This flywheel is well known in Silicon Valley in the tech firms, right? But that's the setup that these guys have put into play. And then, oh gosh, my graphs have been screwed up. And so what we see now today are basically traditional businesses that are siloed. So this is also Harvard Business School. We have a silo for MBA program. We have a silo for the exec ed program. We have a silo for publishing. We have a silo for online. We have a silo for alumni. We have 7 different IT groups. They don't share data. We manage everything through spreadsheets, right? That's just the reality of us as a business school, right? Versus companies that can grow exponentially with data cutting across their entire enterprise, software and APIs driving much of the work inside of those companies. So this future is where we sort of talk about, like, we've gone from a model of my colleague Clay Christensen talking about disruption to one of collision, right? These models are colliding against each other and causing problems for us. And we've sort of seen this, Marriott versus Airbnb. You think Waymo, Tesla versus Ford, HSB versus Ant Group, right? And even Moderna versus Pfizer as examples over and over again. And so let me sort of take you back a bit. When we started researching our book, in the first chapter of our book, we have this image of the next Rembrandt. This image, was really very interesting. It was a project by Microsoft, ING Bank, and TU Delft in the Netherlands to scan every single Rembrandt portrait, then create machine learning algorithms to then generate the perfect Rembrandt eye, the perfect Rembrandt nose, the look, and so forth. Took several months, multi-million-dollar effort, large team. And then this one algorithm built the next Rembrandt. It was a hit. In 2022, it's different now, right? And so, my mother lives in Toronto, and she's like, I read your book barely. It put me to sleep. Tell me how AI matters to me. What does it matter to me? So I asked her, Mom, who's your favorite actor? And South Asians here know that Shah Rukh Khan is her favorite actor, right? So I said, okay, so Shah Rukh Khan is my favorite actor. She watches a lot of Bollywood films. And so I went into Midjourney, $20 a month, and I said, show me Shah Rukh Khan as imagined by Rembrandt. And here's what it gave me. Very beautiful man on this side. And again, $20 a month. And then I'm spending a bunch of time in New York because my wife is studying photography there. So I said, Shah Rukh Khan as a New York hipster, right? As a Brooklyn hipster in a dive bar, right? And then, so again, $20 a month, zero marginal cost, 20 seconds, this image comes out. So what took a lot of effort, right, with lots of skilled people doing lots of programming, lots of statistical analysis, is now available to us as a service, right? And that's what's changed since the book came out. We didn't talk about this at all in the book. We had hints about it, but that's what's changed. And it's a dramatic change, right? Because this is, again, a cute application, but just imagine how marketing changes because now you can create any image on demand. You don't have to do stock photography. You can actually just say, I want this, and be done. How would your marketing function completely get radically changed when this comes true? And so, again, we're still in the world of weak AI, okay, which are ranges of algorithms performing things that humans once did, sometimes good, sometimes bad. We're not in a world of strong AI yet, which is a world of what we call autonomous beings doing their own thing. Although it looks like they're autonomous and smart, it's not the case yet. Different bets as to how soon this will show up. When I was talking to the co-directors of the newly established Kempner Institute at Harvard, which is the Natural Intelligence, Artificial Intelligence Institute, and there's a CS professor and a neurologist as the co-directors. I asked them this question, and they said, 20 years. I was like, I don't think I'm ready for this yet, but 20 years. But for now, we can play here and have fun. So the other thing to note is that there's a ton of hype. And again, if you apply basic economics, the hype exists because the cost to innovate with AI has dropped radically. the example I gave you. And everything is now an AI problem, right? Driving is an AI problem. Dentistry is an AI problem. Credit allocation is an AI problem. Security is an AI problem. So we're seeing this. The reason this explosion hits is because costs have dropped. People are reimagining every single use case as an AI use case, right? And then we see all this hype, all this investments, and so on and so forth. So to put this all into context, we have been living through basically 4 waves of AI, starting about 70 years ago with the cybernetics era, which sort of defined the AI field out of Dartmouth. Then we had expert systems, and that went for a while. But starting in the 2000s, the machine learning systems, the good learners showed up, right? And it was basically tech companies living in a wash of data saying, what do we do? How do we scale ourselves without adding more and more bodies to the problem? They took that, algorithms that were being developed in CS departments and statistics, and with compute started to scale. And then in fact, they became the locus of innovation with machine learning. And now we're in this generative wave, right? And I'll try to explain to you what that is and the consequences of this for us. Of course, you know the story, lots of data, NVIDIA, right? And advances in technology. That's what's driving this, right? And to show this, in reality, I spent some time at Flagship pioneering. They're the guys who helped create Moderna as a company. They're a life sciences incubation studio. And Armin actually made this slide, so I borrowed it from him. Armin is the head of the AI initiatives there. And the diffusion models that do image creation, right? This stuff, I can take Armin's image and then create as many avatars as I want for free. But that same technology, from the lab to acute application to a serious application, Generative biomedicines is creating brand new proteins that don't exist in the world, right? They go beyond what nature has done already. And they're doing this. Now, it's the same underlying technology, but much harder, right? Because they actually have to go synthesize these proteins, test them, make sure they work, and so forth. But this is like the thing. And these guys have raised now in this, with their Series B round, about $600 million in funding to do this work. But the timeline here has shrunk rapidly. So from a toy application to something hardcore is pretty amazing what they've done. Similarly, reinforcement learning, we all saw what's happening with AlphaGo and so forth. And there's so many companies here in Silicon Valley, as well as in Boston, doing drug discovery with reinforcement learning and AI. Again, cute application, fun, right? Serious stuff being done. And similarly, the Flagship company, they're taking large language models and using that to optimize chemistry for molecular nutrition. Montai helped us doing that. So the timeline between lab to cute applications to serious stuff has shrunk rapidly, and lots of stuff is going on in this way. And then to put this again into perspective, again, giving you some frameworks, AI is about incorporating human intelligence into machines. Machine learning takes this trains machines to perform a task. Neural networks, what we're used to, is all about, and deep learning is about classification, right? Or what your phone does, right? Is this Karim or not, right? There's a neural network sort of making a decision for you. And then generative AI is saying, instead of tell me if this picture is my pet, and if it's a cat or a dog, or what kind of cat or dog, we create a new cat that has not existed before. So I was recently with Nitin Noria and at the Versailles, and I went into DALL-E and I said, show me 2 cats having a tea party at the Versailles. And it, again, generated to me this nice, that's all I asked, this very graphic heavy image with the customary macarons, right? And then this photorealistic image as well, right? And so that's what's going on. Now we can create new stuff that has existed before. We're now in that world, not just one of prediction or of classification or pattern recognition. Perspectives on AI, you can see this. Andrew Ng, professor here at Stanford, nothing will be touched. No industry will be touched, will be untouched from his perspective. Sam Altman, co-founder, former chair, former CEO, whatever, I don't know, of OpenAI, AI will most likely lead to the end of the world, but in the meantime, there'll be great companies. I think Dave probably agrees with the last part, right? There'll be great companies with this. The thing that's interesting about him is that he came and spoke at Shikhar Ghosh's class at HBS a couple years ago, and when Shikhar recounted his talk to our MBA students, and this was pre-GPT madness, Shikhar said that one thing he said was shocking to him, that he said that for certain human performance tasks in the lab, they were finding that their models were 1 million standard deviations better than the human average. A million, I don't know how to compute 1 million standard deviations. I did 6 sigma with GE. I can maybe understand 10 sigma. 1 million sigmas, I have no clue, right? And that's part of the worry that I think a lot of people in the West, there's a divide between the doomsayers about AI in the West Coast and then us in the East Coast being much more pragmatic. This is part of the worry, right, about these things. We'll see what happens, how this shakes up. And look, what's interesting is that these systems are performing things they were not trained for, right? So performance in LSAT and so on and so forth. And this is one of my favorite things. I work a lot with our medical school colleagues, and this was a study that came out. Some Stanford faculty members did the study, JAMA Internal Medicine. So it's a reputable journal. There's no plagiarism or anything like that going on here. What they found was that the chatbot, which is 3.5, had better quality than human doctors and more empathy.
Really?
More empathy. So whenever I talk about AI in medicine, they go, but my doctors have such empathy. I go, which doctors are you talking to? Because my doctors are like here. They're like hostile, not even empathetic, they're hostile. And certainly now there's another study from Stanford that showed that they're getting their residents and interns to go to ChatGPT and say, I have this family situation, here's the condition, it's bad news, give me 3 ways to break the news for them. And they find that that's a better way to do it than however ill training they have on having empathy. And again, remember, empathy, we think it's like purely human. Right? This is a human trait. And now these machines are doing it for us. So let me again provide a framework for you. You guys should know what this is. Anybody in this audience know what this is a symbol of? No, not Mozilla. Close.
Earthlink. Earthlink?
No, not Earthlink. Oh.
Netscape.
Precursor. What was before Netscape?
It was before Netscape.
Mosaic. This is what Mark Andreessen created. This is the Mosaic browser that got invented. And the Mosaic browser, there was 20 years of the internet, 30 years of the internet before the internet became a consumer tool, right? Tim Berners-Lee with HTML and web servers, and Mark Andreessen with a web browser basically brought this world to us in 1992, so 30 years ago. When I first saw this, I was working in General Electric, and I was at a radiology conference, and then somebody comes to me and says, a doctor actually from Vancouver comes up to me and says, let me show you the internet. Oh, great, show me the internet, because I've used the internet, I was using email and Gopher and all that kind of stuff before. And I look at this web page. What is it? It's a web page. Okay, it's a web page. HTML. I sort of knew about that. I was reading Wired magazine at that time and so forth. And on the screen was a coffee pot. And he goes, "This is the internet." I'm like, "This is the internet? This is all the hype about in 1992?" Well, what it was what they showed was the Oxford coffee pot, this famous coffee pot done by Oxford University researchers who were too lazy to cross, and we have that at our institute as well. Researchers are too lazy to do anything, and so then they didn't want to check the level of the coffee on the coffee pot and walk across the hall, so they put a camera on top of the thing and put it on the web, right? And so that was the web page. But what was interesting was that all of a sudden, this obscure lab with an obscure coffee pot had global distribution. Anybody with a web browser would have access to the level of coffee in the coffee pot around the world. Cute application. Oh, right? But what does it tell us? Basically, the marginal cost of information transmission went to 0. The marginal cost of information transmission went to zero. And for the last 30 years, we've been living in that world, right? Where now there's massive content creation, but it's easy for us to distribute that. If you remember, there's a world where to get what you do today with FaceTime or Google Meet, right, on your phone, I have to be on brand, you would need a broadcast truck with a satellite uplink to have this kind of a conversation. And we just take it for granted that now you can just be walking around your neighborhood having a conversation with somebody in Japan, right? It's remarkable that this happens. But this was the precursor. The marginal cost of information transmission goes to zero. And then what happens? New companies show up and say, when everybody becomes a content producer, search becomes a bottleneck, right? And we're here because of what Google was able to do with search, right? And a brand new business model, right? New value creation, new value capture that did not exist before, okay? Who still has illegal music in their computers? I still do. So Napster did two things, right? It first unbundled the single from the album, right? That was a big thing, right? And then secondly, it lowered the cost of music distribution, right? And for 3 glorious years, we had all the music we could get for free. And then the record industry got involved. Anyway, instead, what we got now is unlimited music for $20 a month, subscription model. Again, new business models emerge when the cost of music distribution goes to zero. iPhone, right, cost of software development goes to zero. And cost of software distribution also becomes zero, right? Because now you buy everything online through a thing. You still remember going to Best Buy or Sears and buying software in boxes, right? And then walking home with the bags of the software, putting them down, and then like hurting yourself trying to open those blister-proof those things and trying to load the software. iPhone lowered the cost of software distribution and software creation. So any kid from Mogadishu to Montreal, right, to Melbourne, Florida, could be a software developer. And then this gives us this wonderful app called TikTok. So the question is, what is generative AI doing for us? What is that actually unleashing? And the claim I'm going to make is that what it's doing is that it's actually lowering the cost of creativity, lowering the cost of cognition, lowering the cost of problem solving. And that's in line. All these technologies and these approaches have lowered the cost of something meaningful, creating new business models, new businesses, and so forth. What is this doing? This is basically getting us going in this way. And it's a big claim. I put it on paper. We'll see if it's true forever, but I have some evidence to actually point us in this direction already as well. Imagine a job. You're a first-year consultant at a consulting company. You're a first-year banker at an investment bank. All the jobs that HBS alums get when they graduate. We hope that our alums are on this part of the normal distribution, right? But there is a normal distribution. There are people that are most people are at the average. Then there's some people that are on the right tail and the left tail. Well, what happens when all of them have access to a Gemini? Gemini, or ChatGPT or Llama or whatever, right? So the claim we make is that when this happens, the distribution will shift to the right, it will narrow, and probably the left tail will get cut off. Okay? Because now, if this is the average of where the AI is at, then if you're here but you know how to use the AI, you'll automatically get here as well. Okay, so that's what's happening underneath. That's the basic structure that I would argue, if you believe that this is a cognitive shock that we're all going to have to deal with. And we expect 3 distinctive things happening inside of companies. Replacement, a bunch of jobs are going to go away, for sure. Much of this is going to be, in the short term, it's going to be augmentation, right? So now it's like the Tony Stark Iron Man suit. Tony Stark is a mortal, but he can play with the gods because he has our Iron Man suit available to him. So lots of us are getting augmented. And then transformation, right? New jobs are being created that just simply have not been created before as well. And so we see these 3 effects come through. So to make sense of this, and this is again part of like what we've been able to do at the Institute, I spent some time at BCG between my master's and PhD programs. I've been in touch with them as well. And we've been in touch as the institute went up. We've collaborated with them on some cases and so forth. And they said, "Oh, we're launching ChatGPT in our organization soon." And I said, "You guys are going to do it wrong. You guys are going to screw it up." As a professor, I can say that now, right? They're not my clients. I can tell them off. I said, let's run this as an experiment. Let's actually do the proper. You guys talk about A/B testing and experiments. Practice what you preach. Let's actually run this experiment. So what we did with this massive team, Fabrizio Dell'Acqua, postdoc at HBS, Edward McFarlane, professor, Ethan is at Penn, Hila, HBS alum from the PhD program, Kate, HBS MBA program, a bunch of other folks, large team, and we spent from February through May studying what first year, second year, third year consultants do, and then designing a test that would say, for the tasks that these people do commonly, how does the AI perform? And what we discovered was that for the same level of difficulty of tasks, right? So imagine you're a consultant, you're supposed to be good at both the creative stuff, but also the analytical stuff, right? We said, how does the AI perform? And what we discovered is that the frontier of the AI was actually pretty jagged. We didn't know that there's some tasks that are better done by AI, and other tasks that are better done by humans and not with AI. And if you do with AI, actually the performance drops. So we figured that out, and then we ran an experiment. We had 758 consultants work with us for 5 hours each. We randomly assigned them to a control group where they just worked on the tasks themselves, and then treatment groups on the tasks working on the activities to see how well they do, right? And these are people that are from the right tail, right? HBS grads, Wharton grads, Stanford grads, and so on and so forth along the way. And then we see their performance. So here's what we discovered. There's good news and bad news linked to the paper. The nerdy paper is here. One is massive productivity boost, 25% faster, 12% more tasks compared to the folks that are not using AI, okay? Big boost in quality. 40% improvement in quality for the task that's inside the frontier, and I'll give you the task in a second, versus those without AI. These are like crazy high numbers, right? Most of us, if I saw this study and it was not an experimental study, I go, there's something wrong with the metrics, something wrong going on. But because we have a fully fledged randomized controlled trial, I can back this up. And then we see the benefits across skill levels. Now, I have to put in the BCG asterisk. BCG says that there's no consultant below average at BCG. We have a pretest that shows that there is a normal distribution of consultants. And what we find is that those below average improve by 43%. And those above average also improve by 17%. Again, from an economics point of view, these are crazy high numbers, right? We pre-registered our experiment, because if we had not, we would get rejected in most journals because they say like, these are unbelievable numbers. Here's the bad news, right? If you use AI and the AI is not good at the task, your performance actually drops. You fall asleep at the wheel. Okay, and then we also discovered different models of human-AI collaboration. What we saw was centaurs, those that divide the work between themselves and AI, and then cyborgs, those that are actually fully blended with the AI. Okay, so then let me just show you a little bit of detail. So the first one is a creative problem-solving task. We had 18 sub-questions. The question was, you're working for a footwear company in the unit developing new products. Your boss has asked you to present an idea for a new product at the next manager's meeting. Please respond to these questions below. 18 questions. New idea for a shoe, generate 10, blah, 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 all that kind of stuff, okay? So in this, and we've run, what's great is like I can like exercise my econometric muscles. There's like 118 regressions in the back. And I've put them all in the appendix to shut up the reviewers. Here's what we find, right? Again, faster, right, that you see before. And the overview is just a little bit of training about prompt engineering here. 20 minutes of training that Ethan did for us. Then the control. And then performance, quality improved by quite a bit, right? And this is the curve that provides the evidence of what I showed you as a conceptual plot, right? This is a control group and their quality. And then this is these are the treatment groups. And you see the right shift and also the narrowing of the distribution along the way. The thing to note is the following. if you're of median quality here, and the control, with GPT, you get to 96th percentile. Right? And remember, these are already smart BCG consultants. They were selected to do these kind of jobs, and they're getting way better. Okay? And then why is this the case? And this is like an interesting finding. What we're able to do with BCG, and this is again the partnership that we're able to do with our institute, is like, I said, I want everything. It's very greedy. Like, I want a fully instrumented environment. I wanted brain scans, but they said no. And also microbiome, but they said no. But we capture every single prompt, every single thing they did in the 5-hour task. And so then we're able to observe that basically, right, the reason why people do well is because they retain 80 to 90% of what GPT gives them. There's very little modification going on. The answers are so good already that they can go do that already, right? Which means, like, do we need these consultants? What does this mean for our MBA education? And remember, this is off-the-shelf GPT-4. No training, nothing. It's a world model. We just took it, built it through APIs, and made it happen. So this has some profound implications for our MBA program. And then also what we saw is while each person gets better with GPT, their ideas sound the same collectively, because we can do semantic analysis of ideas. And so what this is telling me, and then we'll have some evidence for this as well, this is why we have such a large team and such big collaborations, is that there's a bunch of computer scientists that are now saying, well, let me rerun all the prompts on Llama, on Gemini, on all the other models, and see if, in fact, diversity is enhanced by having multiple models instead of just one model. Right? And the example I go for business, if you are running a soap campaign for P&G for a particular demographic, and using Microsoft Azure services with GPT, and Unilever is also a Microsoft account, and they've also identified this segment as an important segment, and you're gonna run a soap campaign, most likely your ideas will sound the same if you haven't figured this out yet, right? So we're seeing that kind of a thing. Okay, and then the task outside the frontier, this was a task that required you to analyze a spreadsheet as well as these insider interviews about which brands performance is going on. And this is a tricky task because we designed it such that the GPT would fail at it, right? GPT was not able to handle the spreadsheet and the subtle information. And they had to basically do all this stuff, make it happen. So they got an Excel file and a document with interviews. And here's what happened. Control condition, 85% gets right. Those with AI do way worse, about 20% worse. Okay? So again, our smart graduates, right, with AI perform worse than those without AI when the task is outside the frontier. So this is a big worry that we have now, that we see a tremendous upside, but also this downside. Like, how will we deal with this, right? If our students aren't going to be able to recognize what's bullshit from here, right, and make sense of it. And so this is, again, things that we're trying to understand and figure out. Like, those of you that have full self-driving with Tesla, right, if your eyes veer off, unless you're wearing sunglasses, right, the thing beeps at you and calls on you and all that kind of stuff, right? Our models don't do that right now, saying, you've pushed me to do things that I'm not capable of yet, right? They're just like, they're great at providing answers. In fact, I don't have the chart here, but in fact, the answers that these guys wrote up, defending their recommendations, were rated better than the answers from those without GPT. Okay, so they became even better bullshitters, right? Along the way. I've been told I have 5 minutes, and I've got Ailet's study to show you as well. Let me just show you a little peek of Ailet Israeli. She runs our customer intelligence lab. She does amazing study with James Wren and Donald Engway from Microsoft. The punchline is the follows. You can now do market research with ChatGPT. Okay? So I'm gonna flip through again, we'll give you guys the paper. I've lost all this stuff. Okay, so basically the question is, how do we learn about customer preferences, right? How do I know if I want the MacBook Pro or the Surface Pro? This was in front of Satya Nadella when we did this presentation, so we showed the Surface Pro. When we were here, we showed some Google Chromebook, forgot, sorry. And so what she did is can I ask GPT to simulate customers and then do a willingness to pay analysis? The answer is yes. I'm going to move through this super fast. Here's what I want to show you. So you get perfectly nice downward sloping demand curves come in from GPT. Okay, and what you see is that there's a breakpoint as well, and this has been shown to be real, right? At 1,000, if you go more than $1,000 for Surface Pro, people then say, "Oh, I'm gonna buy the MacBook Pro." Okay, and this has been like 1,000 simulations underneath it, and so she's done this with thousands of products. And what the answer is that in fact you can extract both willingness to pay estimates as well as why they're choosing these things that sound very sensible and are consistent with other market research studies that have been done. So the answer here is, if you're now doing market research, right, what you should be doing is go here first, ask these simulated customers. You can create as many personas as you want at scale and do a lot of pre-testing beforehand before you actually go to customers. Okay, I let is like, oh, be careful, don't replace market research, all that kind of stuff. I'm like, just go all in, make it all happen. Again, GPT is price sensitive. Reference price matters to GPT. It has brand preferences, which are simulate whatever the training data is that GPT has, it's quite remarkable what this study has shown, one more on the marketing side, at Grab in Southeast Asia, Anthony Tan, one of our alums, who's a co-founder, they have shown that for all their in-app messaging for customers for promotions, the average time it takes them for them to create a message is 100 hours from the idea to it being launched. 95 hours is idle time. 5 hours is the interaction between marketing and creative. They use GPT-4, 1.5 hours for everything. And click-through ratios are better than those done by human. And even like the marketing team was very skeptical, because they go like, yes, you have the campaign in English, but we need Singlish. All the idiom that's the Singapore is English. Well, GPT does Singlish really well. And they actually ran them with Singlish campaigns and so forth. And so again, the shrinking, and just imagine now, I showed you images, I show you text, this massive reduction, right? How would you now run your marketing group this way?